Okay, well, welcome to two more examples on accelerated motion using the sort of random formulas. This is the day 6 examples in your handout package. So the two things you need are your example sheet, and you need your formula sheet before you begin. So if you don't have those ready, just please pause the tape until you do. Okay, so we're going to do number 2, where we have a motorcycle coasting downhill from rest. So reading the question, first thing I see is from rest. That means I must be starting at 0. And it's got a constant acceleration, for which we don't know. And it says it moves 90 meters. That must be my delta D equals 90 meters in 8 seconds. And so my time equals 8.54 seconds. And find its velocity. So that must be at the end of it all. Okay? So in this case then, like always, the key is to find the formula. In this case, we're not given acceleration. So when you look on your formula sheet, you should see that the very last formula has no mention of A. So look for formula number 5. Has no acceleration listed, so that's the one we're going to use. That formula, of course, looks like delta D so that's what the formula looks like. And we are looking for V2. So you can see there's a little bit of rearranging that's necessary to find V2. You can do that on your own, or you can take the rearranged form off the sheet. Just to remind you, you are welcome to use up your formula sheet, putting rearranged forms. It's better if you can do it on your own by just looking at the problem. But regardless, today we're just going to take the formula, the rearranged form off the sheet, which says that V2 equals 2 delta D So now we should be able to solve for V2 because we have all the information. So it's 2 times 90 minus 0, V1 is 0, over 8 seconds. And so our final velocity will be 22.5 meters per second. And it's fast. But you can imagine going straight downhill for 8 seconds. You're going to pick up some speed. And if I put that in kilometers per hour, you're looking at about 70 kilometers per hour. So it's fast, but it makes sense. It's a reasonable number. Okay, so that's example number 2. We're also going to do example number 3. So if you want to take a look at it. Once again, that's on the day 6 list. And example number 3 is asking for how long. How long can be confusing. Sometimes it can be distance, sometimes it can be time. More often it's time. How long will it take a vehicle traveling at 80 kilometers per hour to come to a stop if its average stopping distance is 76 meters? So I think that's fairly clear. We're looking for time. And again, when I start to write down my givens, I'm going to start with the first thing I see. Delta T is what I'm looking for. How long? It starts at 80 kilometers per hour. Let's just put up here, west is positive. So I can just make that a positive 80. And I'm going to put it into meters per second. So it's 80. Multiply it by 1, my ACU, my convenient form of 1, so 1 hour for 3,600 seconds, times 1,000 meters for 3,600, not 3,600, 1,000 meters for 1 kilometer. So I can cancel my units, get rid of kilometers, I don't want them, get rid of hours, I don't want them, and you end up with 22 meters per second, 22.2. Okay, continuing to read through the question. So how long? We've got that. We've got initial velocity. Coming to a stop, V2 must be 0. If the average stopping distance is 76 meters. So, come down here, W equals 76 meters. Okay. And assuming constant acceleration. So we're looking for time. And the things that we have, again, we're not given an acceleration, right? We've got v1, we've got v2, we've got a distance, no acceleration. So it's going to be the same formula. No mention of acceleration. Well, it mentions acceleration, but doesn't give it to us, and we're not looking for it. So we're going to choose formula 5. So looking down at formula number 5, in the form of t, we have that t equals v1 is the 22.2, 0, meaning that we have a time of 6.8 seconds. Let's see if that number makes sense to us. We're starting at 80 kilometers per hour, and we come to a stop. 6.8 seconds makes sense to me. I'll put a check mark on it. Good answer. Okay, number 5. I was going to do this as an example. I think it's a better one for a bonus. So number 5 on the day 6 examples. It is a thinking type question. It's one you should try. But because everyone will approach it differently, I think it's best not to do it as an example. I think it's best for you to try on your own. So it will be a bonus. And happy to help if you need it.